This is Algebra 2 with Trig, working on Unit 7 review. This is letter B review. Write the first 5 terms of the sequence. Four and 6 is 10. 9 and 6 is 15. 16 and 6 is 22. And the fifth term, 25 and 6 is 31. The first term would be 4 over 3 times 1. Second term would be negative 4 over 6, because 3 times 2 is 6. Negative 4 times 9. Negative 4, that would be 12, so that would be negative 1/3. And the fifth term, 5 times 3 is 15. So those are the first 5 terms. For the sequence, write a rule, the explicit rule. So what I notice is that this is times 2 times 2, so this is geometric. So my first term is 2, my common ratio happens to be 2. So I'm using my format. A of 1, R, and minus 1. So my first term is 2, my common ratio is 2, and minus 1. So that's okay. Or you can say to the n power, to the first, to the second, to the third, to the fourth. That's because this exponent is 1, and 1 plus n minus 1, those cross off, and you're left with n. Looks like 1 squared, 2 squared, 3 squared, 4 squared. So the explicit rule here is 1 over the position squared. This looks like it's going up by 0.6 plus 0.6. Arithmetic. My common difference is 0.6. So my first term is 0.7. You cannot add those together. You have to distribute. 0.6n minus 0.6, and we still have our plus 7 there. So if I'm taking away 0.6, I'm going to have a positive 0.1. So that looks like my formula, and we should be able to test it. Should test all your formulas. 0.6n, and n's going to be like the third number, plus 0.1, we should get 0.19. Write the series in summation notation. I notice the top is 2 times 1, 2 times 2, 2 times 3, 2 times 4. And the bottom is 3 more than the position. So 1 plus 3, 2 plus 3, 3 plus 3. Write the series using summation notation. And it looks like there's 4 terms. find the sum. Well, this is not arithmetic or geometric, so I'm going to have to plug in my first term is really when I'm plugging in a 2. So 2 squared plus 2 plus 4, that's 4, plus 2 is 6, plus 4 is 10. My second term is going to be when I'm plugging in a 3. So 3 squared plus 3 plus 4, that's 9. Plus the 7 is 16. And then my third term is when I plug in a 4. 16 plus 4 is 20, plus 4 more is 24. So my total sum, that adds up to 10. So 1, 2, 3, 4, 5. So that looks like S of 2, 3, and 4. There's 3 terms that you're adding together. The sum of those 3 terms is 50. Tell whether the sequence is arithmetic. Well, it looks like we go down by 7, we go down by 7, we go down by 7, so yes. Why is it? Common difference of -7. And to really show our work, we would say -5 minus the term before it, -12 minus the term before it, so that's -12 plus 5, -19 minus the term before it. So that would be your test. That would be your real work that could show you that that was dropping by -7s, either way. Here it looks like we're going down by 5, then we go down by 5 more, but this time we go down by 2, then we go down by 8. That's not a common, and we're not timesing by the same thing. So it's definitely not arithmetic. Not a common difference. And you could really show that by -5 minus 0 is -5. -10 minus a -5 is also -5, so it's looking good. -12 minus a -10, the term before it, gives you -2. That failed. That was not a common ratio. Sorry you didn't see that. Write a rule for an nth term. We're expecting this to be arithmetic, so we're going up by 6, going up by 6, going up by 6, so the common difference is 6. I like to use our general rule, so we plug in a -4 plus our 6, n minus 1. So that gives us plus 6n minus 6. So we have 6n minus 10. We can always test it. Gives us 6 times, in our position we could say 4. And we minus 10 from that. And we should get the answer of 14 for a 4th term. There it is. So we tested it. A of 10 is going to be 6 times 10 minus 10, 60 minus 10, so that is 50. Here we know our common difference is 2. We use our general rule, and we get a 10 for our 6th term. We don't know what the first term is, but we know the common difference is 2. we get the 10 when we plug in a 6. So this is 10 equals a of 1 plus 10. When we subtract the 10, we get 0 for a of 1. So we have 0 plus 2n minus 1. So our rule is going to be 2n minus 2. When we plug in a 6, we get 12 minus 2 is 10. So that worked out. Our 10th rule, are using the 10, 2 times 10 minus 2, that's 20 minus 2, which is 18. Write a rule for the nth term given 2 points. Well, we can find our slope, or common difference. There's multiple ways to do this, but algebraic way, we can say that the y minus the y over the x minus the x, that gives us negative 6 over 6, which is negative 1. And then we're going to use our general rule. I still don't know what a of 1 is. So I plug in my negative 14. I'm looking for a of 1. I know my common difference is negative 1. 9 minus 1. So that's negative 8, and add that across, it gets you negative 6. So we're going to have negative 6 minus 1 and minus 1. Now you cannot call that negative 7. You have to distribute. So negative 6 minus n plus 1. So our rule is negative n minus 5. So if we plug in 15 here, that would be 15 minus, or negative 15 then, minus 5 more is negative 20. And it works. Find the sum of the arithmetic series. Find the sum. So the sum formula is the number of terms, a of 1 plus a of n over 2. That's our formula for arithmetic finite. We see that there are 15 terms from 1 to 15. Our first term is when we plug a 1 in here, so negative 1 minus 6 is negative 7. Our nth term, or otherwise known as 15th term, is when you plug a 15 in there. That gives us negative 21. So our sum is 15 times negative 7 plus a negative 21 over 2. So that's 15 over negative 14. So 15 times 14, we got 210. That would be negative 210. That would be your sum. Here we do the same thing. We know we have 6 terms. Your first term is when you plug in a 4 to get 24. 24 minus 30 is negative 6. And your last term is when you plug in a 9. 54 minus 30 is 24. So your sum is the number of terms times negative 6 plus 24 over 2. That's 18 over 2. That's 6 times 9. That's 54. to whether the sequence is geometric. So this looks like it goes up by 2, up by 2, up by 2. So this is no, it's not geometric. It does not have a common ratio. This one looks like it's times 3 times 3, or we can say 9 divided by the one before it, 27 divided by the number before it, 81 divided by the number before it. We have a common ratio. Common ratio of 3. Write a rule. So we take our general rule of a geometric explicit, and we know the first term is 2 and the ratio is 3. So that's 2 times 3n minus 1. You cannot call that 6. The sixth term is when we plug in a 6 minus 1. So that's going to be 2 times 3 to the 5th power. 3 to the 5th power is 243. So that's going to become 486. Write a rule for the nth term. Looks like we have 2 points here. So we're going to take our general rule, a of n equals a of 1 times rn minus 1, and we're going to plug a 3 in. We don't know our a of 1, we don't know our r, but we have 3 minus 1. So 3 equals a of 1 r squared, and divide by that r squared gives us our a of 1. Now we're going to do it again using 81. We're going to use this as our 3 over r squared. We don't know what r is, and we have 6 minus 1. So 81 equals 3 r squared r to the 5th. So those can be reduced. 81, 3 r to the 3rd, because 5 minus 2 gives us 3. Now we can divide by that coefficient. Get 27 equals r cubed. And when you take the cubed root of 27 and r cubed, you get 3. And then we're going to plug the 3 back into our formula. 3 over r squared equaled a of 1. 3 over 3 squared equals a of 1. 3 over 9. So 1/3 is our a of 1. So our rule is going to be 1/3, that's our first term, times our common difference, n minus 1. Find the sum of the terms. Well, when we calculate the sum, this is finite. Not infinite, but finite. It ends. It has 7 terms. Number of terms is 7. We know our common ratio is 1/3. And our first term is 90. When you plug in a 1, you get 1 minus 1 is 0. 1/3 of the 0 power is a value of 1. 90 times 1 is 90. So now we're ready to do our formula of a of 1. 1 minus r to the n power 1 minus r. It's our formula. we have 90. 1 minus 1/3 raised to the 7th power over 1 minus 1/3. Now we need to know how to type that into our calculator correctly. So we're going to say 90 times, we have a numerator, so we're going to say 1 minus, I like to put my fractions into parentheses also, raised to the 7th power, and we close our parentheses around the numerator, divided by 1 minus 1 divided by 3, and put parentheses around our denominator. And then we can close off our whole equation. Okay. And if we'd like to turn that into a fraction, we can hit math, the fraction, and that would be 10,930 over 81. We won't worry about doing that all by hand. If you can type it in well, then you're all set. Infinite. So we know it's infinite because of the infinity symbol above it. So this is arithmetic. And arithmetic does not have an infinity option. So this is no sum. That's a U. This is geometric. We see that the R value, let's see, it's infinite also, but we know the R value is between 1 and -1. So we have a sum. So that's A of 1 over 1 minus R. So that's 3 over 1 minus a -2/5. So that's going to be 3 over 5 plus 2/5. So that's 7/5. So we flip it around to multiply it by 5 over 7. That's 35/7. Sorry, you didn't see that. There we go. Showing all my steps. And 35 divided by 7, of course, is 5. Here, just to save us a little bit of room, we know it's geometric. We know the R value is between 1 and -1, and it's infinite. So we're going to use the infinity of A of 1 over 1 minus 2/3. Well, that's 3 over 3 minus 2 over 3 gives us 1/3. Multiply by the reciprocal, and we get 18. And then this one, we see that R is greater than 1. Yes, it's geometric. Yes, it's infinite, but the R value is not between -1 and 1. So this has no sum. What's our total sum? Well, it looks like, all right, these numbers are funny, so I think there might be some reducing going on. I'm going to check to see what my common ratio is. Looks like 3/4. So if we take 1/4 and we divide it by 1/3, that would be 1/4 times the reciprocal. That gives us 3/4. We can try that again. 3/16 over 1/4. That's 3/16 times the reciprocal of 4/1. These are going to reduce to be 3/4. So we have a common ratio. From there, we had times by 4, times by 4, times by 4, 3, 3, and 3, so 3/4. So that's our R value. And it's an infinite. So we have our infinity of 1/3 over 1 minus 3/4. That's 1/3. 4/4 would give us 1/4. So this would be 1/3 times 4/1. It looks like 4/3, otherwise known as 1.33 approximately. But we like 4/3 better. This looks like it goes up by 0.4 and up by 0.4 and up by 0.4. Arithmetic. It's infinite because dot, 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 it goes on forever. So it has no sum. The last page. Recursive. Looks like they give us our first term, they give us our second term, and they want us to do some things. Times 2 back. So we have 1 and our second term. So to find our third term, we're going to go 2 back and say 2 times 5 plus 1 back, which was 2, so that gives us 12. A of 4, we're going to go 2 back, so this is 2 times 2 plus 1 back, that gives us 16. And our fifth term says 2 times, 2 back is 12, so that's 24 plus 1 back, which is 16. 24, that gives us 40. Our first term is 2. Our second term is going to be 2 squared, then minus 3. That's 1. Our third term is going to be the previous term squared minus 3. That's 1 minus 3, which is negative 2. Take our previous term, square it. That's 4 minus 3, which is 1. And take our 1 square minus 3, that's negative 2. It looks like we're going to keep alternating back and forth. Write a recursive rule. So it looks like we go up by 2, up by 2, up by 2. So we have a common difference of 2. So this is arithmetic. So A of 1, our first term is 2. And our rule is to take the previous term and add 2. Pretty simple to write those rules. Times 3, times 3, times 3. This is geometric. So the R value is 3. So our first term is 2. And our rule is 3 times the previous term. Alright, so this goes up by 2, then up by 1, then up by 3, so that's not it. So we're going to compare it to the numbers 1, 2, 3, 4. If we square this, we get that. So we try squaring, but that didn't work. We try cubing, but that didn't work. Sometimes we got to add or subtract to those, but that didn't work. If you take a notice, these two numbers, 1 and 3, add to be 4. 3 and 4 add to be 7. 4 and 7 add to be 11. So the rule is to take two numbers, and then to find the pattern, you take two numbers back and you add it to one number back. And you can go in either order here. Sum doesn't matter. Okay, last one. A tree farm initially has 5,000 trees. Each year, 10% of the trees are harvested and 450 seedlings are planted. Write a recursive rule for the number of trees. So we know that in the beginning, we have 5,000. And the pattern's going to be to take each year 10% are harvested. That means you keep 90% of the trees. So you're going to get 90% of the previous year. And then you're going to add 450 new trees. Those are called seedlings. How many trees remain at the beginning of the 5th year? Well, we can test this out. We're going to start out with 5,000. We're going to do 0.9 times our previous amount, and we're going to add 450. So A of 1 has 5,000. $450. 4,950. 4,905. 4,864.5. So here, if you had to call it a specific tree, I would just call it 4,828 trees. But we're showing the mathematics all the way through. What happens to the tree population over time? Well, what we want to notice when we keep going, what we're looking for is when 10% is going to be the same as 450. That does seem to just be dropping, but we're trying to find 0.9. So I'm looking for when 10% is the same as 450, and it'll start to slow down, and I think we're starting to reach that amount. So it looks like we're going to keep 4,500 trees, no matter how far we go. Over time, let's see, 10% of 4,500 is 4,050. Add 450, returns total to 4,500. And we do it again. We take 10% of that. We add the 450, takes us right back to 4,500. Therefore, trees will approach 450 trees. That's the total.